guys, today we are going to continue our multiplication unit and hence fun problem number 4 instead of fun problem number 1. So let's do this. So we have find the product. So I'm like, okay, so we have a 2-term expression times another 2-term expressions, or using my fancy math words, we got a binomial times a binomial. So to guide me in the multiplication process, when we have product of binomials, let's go ahead FOIL it out. Okay, so we're going to use FOIL to guide us in the multiplication process. If you don't want to use it, that's fine. Okay, you'll get the same answer. Okay, so round 1, what do we get when we distribute the A? Oh, I'm not going the FOIL route, sorry. So F, product of the first terms. So product of the first term, let's go ahead, take the first term in the first binomial, identify the first term and the other binomial, and then we'll take their product. Product of the first terms gives us A squared. Yeah, so I was going to say like if we were not going to use FOIL, but yeah, let's do this. Oh, product of the outer terms. So ignoring all the parentheses, I need you to identify the terms that are on the very outsides. So out times out. And the product of the outer terms, namely A and negative B, will give us negative AB. Okay, we keep our cool. I, product of the inner terms. So if you ignore all the parentheses, I need you to identify all the terms that are at the very inside. In this case, it's B and A. Product of B and A is just BA. But love yourself, because look what happened in the last problem that we did. Put the variable factors in alphabetical order. So instead of doing BA, we'll switch it up and say AB. Okay, awesome. Keep it going. L, product of the last terms. So we're going to identify the last term in the first binomial, identify the last term in the second binomial, and then take their product. And the product will give us negative B squared. Fantastic. So we multiplied it out, so we're good. But we always, after we multiply, we see, we check to see if we have any like terms. And in this case, the middle terms are like terms because they have the same variable part, namely, you know, A, B. Oh, I want some of those, some abs. So let's go ahead, combine them. So we have one A squared term, bring it down as is. And we combine the middle terms. The coefficients are -1 and +1. If you need a special effect one, go for it. If you don't need it, then I don't need it. But again, I always need it. Yeah, you cannot see that. That didn't work out nicely. Remind me not to use this highlighter again. Okay, that just made it worse. Alright, there's no winning. Alright, let's do this. So -1 plus 1 will give us 0. So we'll say that they cancel out. So the AB's are out, and we're just left with the minus B squared. Fantastic. So today we are going to be looking at our multiplication shortcuts. So multiplication shortcuts. So I'm hoping that I'm gonna convey what I'm trying to say, and if not, if you're like, no, Miss Torres, I don't really get it, then please keep practicing, okay? And if you're like, no, I don't want to get it, then it's okay. You don't have to take a shortcut. If you get it, cool, it's a shortcut. And if you don't get it, then it's not a shortcut for you. Just multiply however you can, how we did in the last video, okay? Before we introduce our first multiplication shortcut, though, we gotta talk about conjugates. What are conjugates? Conjugates are binomial expressions that differ in a sign, okay? So the question is, how do we find the conjugate of a binomial? So let's go ahead and do this. So I'm going to pretend like I read this to you. To find the conjugate of a binomial, we're going to copy the first term as is and then take the opposite of the second term. So I'm like, copy, opposite. Conjugate of A plus B, copy, opposite. Okay? To find the conjugate of a binomial, copy the first term as is and take the opposite of the second term. Now, on that note, what's the conjugate of A minus B? We're like, oh, conjugate, we got it. Copy, opposite. We copy the first term, and then we're going to take the opposite of the second term. Cool. So let's go ahead some practice with these 4 fun problems. So we have conjugate of x plus 3 is, remember, conjugate, copy, opposite. So we'll copy the first term and then take the opposite of the second term. So the conjugate of x plus 3 is x minus 3. And then you're walking down the streets and someone says, hey, what's the conjugate of 2x minus 9? You're like, I got you. Conjugate, copy, opposite. And then another stranger says, hey, what's the conjugate of negative 4x plus 5? You're like, I got you. Conjugate, opposite. And we're gonna, who are we kidding? No one's gonna ask you this question, but that's how I speak. Okay, so what is the conjugate of negative 6x minus 7? We're like, let's do this. Conjugate, copy opposite. So I understand that I sound like a broken record, but I'm hoping that if I say this like plenty of times, maybe it will stick to you. Okay, so with that being said, let's introduce our first multiplication shortcut. So there's a lot of words, okay, but this is the problem. It says a plus b times a minus b equals a squared minus b squared. And it's like, oh, I'm scratching my head, pretend you can see my face. I'm like, that answer looks kind of familiar. A squared minus b squared. Where did I see that? Well, that's actually the answer that we got before, okay? Where did this answer come from? We had, let me see if I can zoom out as much as I can. Okay, that's as much as I can go, okay? So, our answer was a squared minus b squared, a squared minus b squared. Where did that come from? Problem was a plus b times a minus b, and the answer was a squared minus b squared. Oh, multiplication shortcut. A plus b times a minus b equals a squared minus b squared. Why is this the answer? Is it because teacher said so? Because book said so? No, because you discovered it, okay? It comes from math, okay? So let me go ahead, zoom in. So, depending on the book that we're working with, and that will determine how they will name it, okay? But for the most part, this multiplication shortcut is addressed as product of a binomial and its conjugate, which is a pretty long name, but it's actually the most appropriate name. Why? Product of something, so we're multiplying. What are we multiplying? Product of a binomial. So we have a binomial and we're multiplying it by its conjugate, okay? So conjugate of a plus b, conjugate, copy opposite, okay? This multiplication shortcut is also known as a difference of squares. Why? Well, the reason is because the product of a binomial and its conjugate always simplifies to a difference of squares. So if this is your question, then that's your answer. So you can label it however you like, okay? So that's it. Something that I want to point out is this in terms of identifying A and B. So A is the term that appears before the operation, okay? So in this case, A is A. Well, this is going to be weird because we don't have an example, but I'm hoping to expand on it on the actual problem. B, what is that? B is the term that appears after the operation, so after the plus or minus, okay? So if this is your question, that's your answer. A squared minus B squared. You're going to take the first term and score it. Always minus. Why minus? Because it comes from our math, okay? But the title, difference of two squares. So we have, if this is your question, then that's your answer. A squared minus B squared. So you're going to take the first term and score it. Always minus. You take the second term, square that. Okay, that's too much foo-foo-doo-foo. So let's go ahead and knock out fun problem number 5. So fun problem number 5, we have 4 problems, but we'll do one just for added fun. We'll do it twice for added fun. Okay, so the directions read, because we always read the directions. Perform the indicated operation. You are encouraged to take a multiplication shortcut if possible. So I want to point out this. You are encouraged, okay? You are encouraged to take a multiplication shortcut. We haven't taken one yet, okay? But after this unit, you know, when you do your homework, you take a quiz, you take your test. If you feel comfortable to take a multiplication shortcut, then go for it. But if you're like, nah, I'm not really feeling it, it's okay. Do what you gotta do. Okay, so let's go ahead and do our first of 4 problems. Let me zoom out. Okay, so problem A, we have x plus 7 times x minus 7. Okay, so if I see this on the test, I'm gonna go ahead foil it out, or I'm gonna ask myself, can I take a multiplication shortcut? So I'm a little tired, so I'm gonna do it without the shortcut because I need to fall back on what I already know. Again, master what you previously learned, and then you're good to go. Binomial times binomial. Let's go ahead foil it out. So let's go ahead use FOIL to guide us in the multiplication process. So we have f. Product of the first terms. Product of x and itself will give us x squared. O, product of the outer terms. Product of x and negative 7 will give us negative 7x. I, product of the inner terms. Product of 7 and x will give us 7x. L, product of the last terms. Product of 7 and negative 7 will give us negative 49. Okay, so we found our 4 products, so we're good. But now we have to take our time and see if we have any like terms to combine. In this case, the middle terms are like terms, so let's go ahead and do this. So that will give us x squared minus, okay, I jumped the gun. Okay, the middle terms cancel out, and that will leave us with x squared minus 49. Oh, I got lucky that I had the minus 49 still. Okay, so we're going to do this problem one more time. So we're going to call it A2 because we want to highlight that it's the same problem but then again. Okay, so we have x plus 7 times x minus 7. So I see this on the test. I'm like, okay, we got product of two binomials. Let's FOIL it out. But then I'm like, wait, can I take a shortcut? Oh, I don't know. Do I got a product of a binomial and its conjugate? Because I'm like, the binomials look kind of the same. Are they conjugate? Maybe, maybe not. So conjugate of x plus 7, copy, opposite. Oh, I'm crying because they're conjugates. So let me speak to myself. Okay. Alright, conjugates. So we have product of conjugates. Okay, so let me remind myself of the formula. If we have product of conjugates of the form a plus b times a minus b, if this is your question, then this is your answer. A squared minus b squared. Remember, product of conjugates simplifies to difference. That's its difference. Difference of squares. Product of conjugates simplifies to difference of squares. So let's do this. So now let's go ahead and identify A and B. So A is whatever you see before the operation and B is whatever you see after the operation. So again, with the multiplication shortcut, product of conjugates simplifies to difference of squares. If this is your question, then that's your answer. A squared minus B squared. So what are we going to do? We're going to take our first term, namely A, and then square it. Always minus. Second term, square that. We take our time. Square of x is just x squared and square of 7 is 49. Okay, now depending on how comfortable you feel with these problems, for these multiplication shortcuts, if you want to go from question to answer, go for it. For other questions where we don't have multiplication shortcuts, then yeah, you show your work. Okay, so as promised, we're gonna do how many problems did I say? 4. That was our second one. That was our first one. I lied. Let's go ahead and do 3 more. Let me see if I can do this in the back to save paper, you know. All right, problem B. Problem B, we have 2x plus 9 times 2x minus 9. Okay, so on the test you can FOIL it out. It's cool, but again, the only way that I'm going to feel comfortable with the multiplication shortcut is if I actually give it a shot. Okay, so I'm like, okay, the binomials look kind of the same. Are they conjugates? I hope so. Let's cross our fingers. Conjugates, copy, opposite. Yeah, they sure are conjugates. So let's go ahead and do this. So let me remind myself. If we have product of conjugates, I need to write better. If we have product of conjugates, then now that will always simplify to a difference of squares. So I abbreviate it. Oh yeah, you cannot see that. Sorry. Okay. Product of conjugates will always simplify to a difference of squares. So let's go ahead and write it. A plus b times a minus b equals a squared minus b squared. Okay, this is your question, this is your answer. So let's identify a and b, square it, and then we're good to go. So the first term is a, that's the first term is 2x, that's our a. The second term is 9, so that's our b. So let's do this. If this is our question and this is our answer, product of conjugates will always simplify to a difference of squares. So we're going to take the first term and square it. Always minus, hence the difference of squares. Always minus, second term, and square that. Okay, the square of 2x times another 2x will give us 4x squared. And the square of 9 is equal to 81. Okay, and if you're having a moment because you're like, oh, what if I took the shortcut, what if I applied the shortcut incorrectly, then FOIL it out and we'll get the same answer, I promise. Okay, so again, 4 problems. That's our second one. We got 2 more and maybe we're out. Okay, problem C. We have 13 minus 4x times 13 plus 4x. So I'm like, okay, my first reaction is like, oh, we got binomials, product of binomials, FOIL it out. But then I'm like, wait, you know, let's see if we could take a shortcut. The binomials look similar. Are they conjugates? I'm crossing my fingers, pretend you can see them. Copy, opposite. So yep, they're conjugates. I'm not gonna write the rest of the speech. I wrote it again because I was writing on the new sheet of paper. So product of conjugates will always simplify to a difference of squares. So I always like to speak to myself. I write everything fully at least once and then just write a summary thereafter. So let's go ahead and identify A and B. So A is whatever you see before that operation and B is whatever you see after the operation. So I understand that 4x because of the subtraction sign is negative, but what I said in the earlier page, you know, A and B are the terms that appear before the operation or before the plus or minus. And if we're having a difficult time accepting that B is positive 4x, then jump to the one where we have a plus sign. A is whatever you see before the operation, B is whatever you see after the operation, and then we get over that hump. Okay, so do what you gotta do. Okay, so product of conjugates simplifies to difference of squares. So let's do this. So the first term and our answer should be of the form a squared. We're going to take that a and square it. Always minus b squared. We're going to take that second term and square it. 13 squared, who knows? Let's punch it in. That will give us 169. And the square of 4x, 4x times 4x, because I don't have that many fit in many digits. 4x times 4x will give us 16x squared. So we multiplied. None of these terms are like terms, so we're good. The question that I get is, do we have to write the terms in descending order? It is customary to write the terms in descending order, but the direction says, sorry, I stabbed myself with this pen. They're pretty nice, but they're dangerous. Okay, so it says so again, we are trained to write the terms in descending order, but I gave you the green light. It says you do not have to write your polynomials in descending order. And that's because I was anticipating the multiplication shortcut. But you know what? If you're going to sleep better, if you put it in descending order, then go for it. Okay. Final problem. Okay, where am I? Problem D. It's D, so it has to be spicier. Okay, so we have 6 times w to the 4th minus 5 times w cubed multiplied by, you guessed it, is conjugate. Oh, I'm so predictable. Okay, so let's do this. Just as predictable on the test. Fantastic. So again, you see this problem, you want to fold it out, go for it. But we notice that the binomials are the same, so I want to know, do they have a special relationship? Oh, I hope they do. You know, I hope they're conjugates. Okay, copy opposite. So yep, let's go ahead, talk to ourselves. So we have product of conjugates. That makes me happy because that means that we can take a shortcut. Product of conjugates will always simplify to a difference of squares. So remember, if this is your question, this is your answer. If you have product of conjugates, whether you have a plus b in the beginning or a minus b in the beginning, the moral of the story is product of conjugates will always simplify to a difference of squares. So let's identify a and b so we can be out. So a is whatever you see before the operation, and b is whatever you see after the operation. Again, if you're having a moment with the minus, then ignore it and go straight to the one that has the plus sign. A is whatever you see before the operation, and b is whatever you see thereafter. So let's do this. If we have product of conjugates, our answer should be a difference of squares. So let's do this. A, where am I? In this case, a is 6 times w to the 4th, so we have a squared minus b squared. B is 5y cubed, and we're going to square it. So are the variables in my way? Yeah, but we got this, okay? So when we square 6 times w to the 4th, let's do this. The square of 6 times 6 is 36. And the square of w to the 4th, w to the 4th times another w to the 4th. Yeah. W to the 4th times another w to the 4th. How many w's are we multiplying? 8. Yeah, I know you like my fingers. Cool. Minus, okay, square of 5y cubed. The square of 5, that will give us 25. And the square of y to the 6th, sorry, the square of y cubed, y to the 3rd times y to the 3rd. I guess we're multiplying 6y's, okay. What if you're like, no, Miss Torres, put your fingers away? Okay, then we'll bust out the power rule from an earlier video. Okay, so power rule. If we have a factor and you raise it to some power, how are we going to do that? How are we going to simplify it? You're going to keep the base and multiply the exponents. Okay, so if you want me to put my fingers away, I don't know why you would want to. If we apply the power rule, y to the 3rd raised to the 2nd power, y cubed raised to the 2nd power, power rule, we keep the base and multiply the exponents. Okay, so that's it. Cool. So I think to minimize the length, we're going to stop right here, and then we'll introduce our second and final multiplication shortcut in a later video. Thanks, guys.